Hi, this is my third session, strength of materials. How to draw the shear force and bending moment diagram for combination of concentrated and distributed load. All right, for the first session, I focus on concentrated load only. The second one is I share about the distributed load, but in this session, we will combine it together in one question. Okay, this is our question. We have a distributed force here, and we have a concentrated force, and we have a concentrated moment here. All right, so but my dimension is not very clear here. This one is a 5 meter, and this one is a 5 meter, and this one is a 5 kilo newton over meter, and this one is 15 newton, sorry, kilo newton, and this one is a 80 kilo newton meter for our concentrated moment. All right, you have to remember what I have shared to you in the first session. You have to remember three main steps you have to follow. The first one is a FBD. You have to draw the FBD. All right, the second one is a summation of f equal to 0. I declare upward is a positive, and the third one is a summation of m equal to 0, and I declare clockwise is a positive. All right, we go to draw our free body diagram. Okay, this is our free body diagram. We start with the beam here. We start with the beam. Okay, this one is our moment. We focus to our external load. Okay, 80 kilonewton meter, and we have a 50 kilo newton, and we have a distributed force here. Okay, distributed force. This rectangular shape. Okay, if we have a distributed force, for sure we will have a representative force here at the center. Okay, uh all right, done. Then we have our support here. If we have this one is a roller type. If a roller type, there is just one single vertical force here. All right, I name it as a VA. Then for this one is a pin support. We have a two force. One is a vertical, then the other one is a horizontal force. The horizontal force here is equal to 0. Why is equal to 0? Because it is the only horizontal force acting on the beam, so it is equal to 0. Then this one, the vertical force here, we name it as a VC. All right, so from this point, from A to B here, we have a 5 meter, and from here, from this point B here to our representative force is a 2.5, is half of the total length for the 5 meter for the distributed length. All right, so this one is a 2.5. All right, okay, so what's the value for the representative force here is 5 kilo newton over meter, multiply with our 2.5 meter, sorry, 5.5 meter. All right, 5 meter, so we can sort out the meter, and we get a 25 kilo newton for the representative force. All right, done our FBD, but we still don't know our VA and our VC yet. It's okay, we will calculate it. All right. Okay, for the second step here, for the second step, summation of f equal to 0, and I declare upward is a positive. So how many forces do we have here? 1, 2, 3, 4. So 4 forces to sum out. For the first one is VA, upward is a positive, downward is a negative 15. So we have another one is a negative 25, and the other one is a VC plus a VC upward direction. So equal to 0. Then we have here we have to solve the equation VA plus VC we equal to 3040. All right. Okay, next for our third step here, summation of m equal to 0. Yeah, summation of m equal to 0. I declare clockwise is a positive and the moment is at point C. All right. So how many moment do we have here? We have a one concentrated moment here, and we have a four concentrated forces. So that means these all forces which will develop a moment. So that means we have a one, two, three, four, five total moments to sum out. All right. The first one is a 80. We have a 80 here, and then we have a VA. VA we have to multiply with the distance here is 10. So this one is a positive. The moment is a positive. If you forgot or you don't know how to identify the positive and negative for the moment, I hope you can refer back to my first session. I have already discussed about it. All right. So we continue. 15 here multiply with the distance 5, so it's a negative moment, and this one the same condition, negative 25 multiply with the distance here 2.5, and then we have a VC multiply with 0. All right, and equal to 0. 1 2 3 4 5, 1 2 3 4 5. All right, so you have to solve the equation. At the end of the equation you will get a VA equal to 5.75 kilonewton. All right, when you get this a value of VA, you can get a value of VC here. All right, so the VA plus VC equal to 4, oh sorry, equal to 40. The VA is a 5.75 plus a VC equal to 40. So VC is, the value of VC is 34.25 kilonewton. All right, so our VA value is a 5.75, and our VC is 34.25. Okay, so our FBD now is complete. Okay, now we have to do our imaginary card. Okay, we have to do our imaginary card. The first imaginary card here at this range. All right, at this range from 0 to 5. So our imaginary card is a 0 from 0, sorry, 0 to 5. Okay, you have to do the free body diagram first. All right, this is our free body diagram. Let's say I cut at a point here. Okay, when you cut, for sure there is a shear force, internal shear force, and the internal moment here, and we have a external moment acting, and we have a corresponding force uh, from this support. All right, for this roller support, we already get VA here is a 5.75, and then we have X for the distance. All right. For the second step here, summation of F. Okay, summation of F equal to 0. I declare output is a positive, so the output is a positive 5.75. Okay, 5.75 minus a V cut equal to 0. So V cut is 5.75. All right, then we go to the third step here, summation of M. So our summation of M equal to 0. I declare clockwise is a positive, and our moment here I define it at cut point. All right, sorry, we have a cut point here. We have to mention cut. All right, 0. Okay, then how many moment do we have here? We have one, two, three, four moment to sum out. All right, the first one is 80. The first one is 80. uh this one VA multiply with X. Okay, this one is positive, and this one, oh, we have a V cut here. Our V cut here have to multiply with the distance is 0. All right, just put plus, and then we have a negative M cut. All right, so we have to solve this equation. This means you will get at the end of the equation, you will get M cut equal to 5.75 x plus 80. All right, this is the linear equation. Okay, let's say if the x value is 0, if the x value is 0 here, if the x value is 0, that means the m cut, the m value will be 80. All right, okay, if the x equal to 5, you will get the m value equal to 108.75. This one is a kilonewton meter, and this one is a kilonewton meter. Sorry, for the V cut here, we have a unit of kilonewton. So, done for our first cut, our first section from 0 to 5. Alright, then we have to do the inventory cut at this section from 5 to 10. Alright, okay, for the second cut. For the second cut here, from the X value is from 5 to 10, equal. All right, you have to remember, you have to do these three main steps that we have to follow. All right, the first one is a FBD. Let's say we want to cut at this point. All right, we want to cut at this point. We want to cut at this point, so we have to draw the FBD. Okay, we have to draw the FBD. Okay, this is a cut point. We have a shear, internal shear force, and we have a moment here, and also we have a external moment 80 kilonewton meter, and we have 5.75. We have a 15. We have a 15, and then we have a distributed force. Okay, distributed force. Rectangular type, and we have a representative force here. All right, okay, this is our length. The total length is x. Okay, all right, we have to define it. Okay, this one is a point, and this one is a cut point, right? So the distance from the 15 here, from the point A, from B to C, from to the cut point, so that's mean the distance is x minus 5. All right, what happened to this one? Okay, this one, the distance is from the representative force here to the cut point, x minus 5 divided by 2, half of the length. All right, so what's the value for the representative force here? Representative force here, we have a 5, we have 5 kilonewton meter multiplied with the total length of the total length for the distributed force here, x minus 5. All right, that one is the force. Okay, to make it simple, we just put it without units, yeah, without units. Sorry, 5 multiply with, all right, for the force here. Okay, okay, done for the FVD for the second section. Okay, we go to the second step. It's a summation of F. Summation of F equal to 0. The upward position is positive. How many forces do we have here? We have a 1, 2, 3, 4. 4 forces to sum up equal to 7, equal to 0. So we have here 5.75. Then we have a 15, negative 15 here. Okay, negative 15. So we have another representative force here, negative 5x minus 5. All right, this force, the force. Okay, then we have a v cut. So we have a v cut negative, oh sorry again, negative v cut, okay, equal to 0. 1, 2, 3, 4. 4 forces. That means 1, 2, 3, 4. 4 forces. Okay, now then after you do this equation, at the end of the equation you will get one linear equation. Okay, v cut equal to negative 5x plus 15.75. all right, this is a linear equation. Let's say the x value is 5. Okay, the x value is 5 at this point. Okay, x value is 5. So if the x value is 5, the v cut value will be negative 9.25. If the x value is 10, the v cut will be negative 34.25 kilonewton. Okay, this one, both of them is a kilonewton. All right. Okay, for the last step here, we have a summation of m, right? Okay, we have to do the summation of m. Summation of m equal to 0. The clockwise is a positive. All right, the clockwise is positive. So how many moment do we have here? We have a 1, 2 moment, and 1, 2, 3, 4. 4 forces which will develop a moment. So that means we have a 6. We have a 6 moments to sum up equal to 7. All right. So here I declare the moment at the cut point. Once again, I forgot to write down here. M cut at the point cut equal to 0. All right. Okay. So we start from here. We have an active. We have a active. This one's a positive moment. Then we have a 5.75 positive multiply with our distance. Our distance is x. All right, this one is quite complicated. Then we have a force here 15 multiply with our distance from the representative load, from the B point to the cut point here is a x minus 5. All right, x minus 5. So this one is a negative. All right. Okay. This one for the representative force here, we have a 5x 5. This one is the force. All right. This one is a force. Multiply with the distance. The distance is the x minus 5 over 2 from the representative force here to the cut point. So x minus 5 over 2. Alright, minus 2. Okay, this one is a negative. And also we have here v cut. minus uh, the v cut of is okay, because the v cut we multiply with the 0, and then we have a negative m, so equal to 0. All right. Okay, this is the equation. You have to simplify the equation. You have to solve the equation. At the end of the equation, you will get a negative 2.5 x power to 2 plus 15.75 x plus 92.5 equal to 0. Okay, this is a quadratic equation. All right, quadratic equation. Just now we got linear equation for our shear stress, shear force. This one is for the moment we got a quadratic equation. All right, let's say the x value is 5, you will get the m cut equal to 108.75. All right, sorry, this one supposed to be m. Okay, all right. If the x value is 10, the m cut will become 0 kilonewton meter. Okay, done for the second segment. Then we have to draw, we are ready to draw our shear diagram and the bending moment diagram. Okay, for the shear diagram and bending moment diagram, I'm using a new paper. All right, I refer back to the question or our FBD. It's a very easier for us to draw the diagram. Okay, I draw the axis first. Okay, this one is a V. This one is a V. Okay, this one is a V, and the unit is a KN, and this one is our X, and the unit is meter, and this one is our other axis. We have a V here, and our X meter. Oh, sorry, this one is our M. The unit is a kilonewton meter. All right. So here I divide our graph axis here into 3 parts. Okay, sorry, 2 parts. Okay, this one is 0, this one is 5, this one is 10. 0, 5, 10. All right. For the first segment here, I refer back to what we have computed just now. All right. Okay, refer back here. So what happened to the V cut here? V cut is a 5.75. So that means we have a 5.75 here. Okay, 5.75. We just draw a one straight horizontal line here. All right. And what happened to the shear force? So the moment here we have a 5.75. 5.75 plus this one is a negative. If the sorry, I refer to this one. Okay, this one. Okay, 5.75 x plus 18. If the x is 0, if the x is 0, wait. Okay, easier. Okay, if the x is 0, the m is 80. All right. If the x is 0, the m is 80 here. If the x equal to 5, the m will become 108. Okay, 108.75. Correct. So this one is a linear equation. It's a positive. So the slope is upward. One line. Okay, done for the first section. Okay, so we go to the second section here. Second section, what you can see here, oh, we have linear equation for the shear force. All right, so we got here, let's say if x equal to 5, the v cut is negative 9.25, so that's mean negative 9.25 at this point. Okay, and if the x equal to 10, the v cut is at negative 34.25, negative 34.25. All right, negative 34.25. So we just plot it here. Okay, that's me. This one you have just connect it. All right. This one is a linear equation. That means we have a graph, downward graph, because we have a negative. We have a negative slope here. All right. So we just close up our graph. Okay, so the maximum value is done for the shear force diagram. Okay, so the maximum value for the shear force is 34.25. It's not a 5.75. Okay, negative is just for the direction only. They just want to show the direction. So the maximum is at this point. All right, 34.25 for the maximum shear. All right, for this bending moment, we have a quadratic equation here. Quadratic equation. If the x equal to 5 is at the point here, 108.75. If the x equal to 10 is x is 10, so the m value is 0. Okay, so it's a quadratic. If it's a quadratic equation, if it's negative here, so your trend of your graph will become like this one, the set one, negative. If positive, you will get this kind of trend. Okay, then you have to do this quadratic graph here. Okay, all right. So the maximum bending moment here is 108.75 at this point. All right, we have done our diagram. So if you have any problem, you can email me at azwan.nasi@gmail.com. Then we will see you again in our next session. All right, thank you, bye.